Kilo 7 Alpha Golf Echo.
Kilo 7 Alpha Golf Echo. Randy, you're 5'9", Charlie Oscar 5'5".
Hi, this is Randy from the Basement Workshop, working on another antenna project. The last antenna project I did down here was basically pre-assembling my Navasa 5 HF beam. But now I'm working on my satellite stuff. Back in the mid-1990s, when I lived in Grass Valley, when we bought the house, a ham owned the house, but I didn't know him. It was Bob NA6E back then. He's a silent key now. And he had taken all his HF stuff down, but he still had his Oscar 13 system set up. So he had a pair of KLM 22Cs. So these are 11 elements vertical and 11 elements horizontal, circular polarized. 2 of them phase together, and a 38 element for 435. So when I moved back in 2015, I tore all that down, and it's just been sitting in storage ever since. So up on the top of the tower, I had one of these Yaesu. It's a G5400. It's an older previous model. And I remember having a problem with it that it wouldn't turn in one direction. And what Yaesu does on here is that you have an up and a down button and a left and a right button. So they, when you push the switch down, it grounds a signal going into the transistors that fire a relay to turn the antenna. But they pass the ground of the second switch through the first switch. So if the first switch isn't making its normally open contact, you can't turn it the other direction. So I actually bought some switches, and of course I put them away in a safe spot. And when I was looking for something else here, I found them, but I didn't need them. So up at the top of the tower, just a few feet down from the rotor, I had these 6-pin Molex connectors, and then the cable ran from the connector all the way back into the shack, and I screwed it in using terminal lugs into the back of the rotor. And when I fired this thing up here, or when I was putting it together, I noticed that one of the pins on one of the cables was broke. So I have no idea when that happened or if it was intermittent, but I dug through my junk box. I knew I had Molex connectors, and I found a pin, so I was able to solder on a new pin and put it in there, and the rotor controller has been working just fine. And then I discovered that the lamps for the meters were both out, and it's a little incandescent lamp. I have a close-up picture here. It's about a 1/4 inch in diameter, maybe a 1/2 inch long, on a little piece of phenolic board with a couple solder pads on there. And it's wired up to the 12-volt AC secondary winding of the power transformer. So they're running 12 volts AC through the lamps. And so I thought I'd get some LEDs. I put some LEDs in there, and I'm running them off of AC. So yeah, if you scan your eyes back and forth, you may see like a 60 cycle flicker, but that was the easiest thing to do. And then between the 2 LEDs on a little board I put a current limiting or voltage dropping resistor between the 2 LEDs to take and set the current. And I have it kind of low, but you can see they're actually white LEDs, but the top of the meter must be green in there. Anyway, it looks good. So the other thing I noticed when I first fired up is that the elevation meter was jumping all around, which means there's a dirty pot up in the rotor unit. But after running it back and forth a few times, it's perfectly smooth now. So that's kind of important, because I will be controlling this with a CSN SAT satellite tracking box. So we'll get into that later. It plugs into the back here, and we'll take and automate things. So here I have the rotors just sitting on the floor. When you buy this new, there's a bracket that's used to attach the elevation rotor to the top of the azimuth rotor. Of course, I lost that a long time ago, and I had a mast clamp on the top because the rotor was down in the tower on a mounting plate. Then the mast ran up through, and the elevation rotor was on the top. So I took some of this military mast, aluminum mast tubing, and I cut it, and I put that in there. And then I had to order from DX Engineering a lower mast clamp. because I'm not mounting this on a tower. In fact, I'm not really sure how I'm mounting this yet, but I'm working on a temporary solution. So what I have here is a tripod that uses military masts. So what's neat about this is that you use the mast tubes for the legs. Here I just have one, but you could have two tubes connected together in series. And what's really neat about it is this centerpiece. So all the legs fit in there. And if you were putting up a mast, I would probably have two legs in each one, because then you can push the mast up through the bottom to take and raise it. So what I'm doing is I'm drilling a lot of this out, and I'm putting in these pins here because I don't want the legs to slide out if I'm moving it around or anything like that. So I have this one in the bottom that sets this. I have one up here that it's kind of sitting on that, the weight, until you get that one in or whatever. So I got two there. I have to drill the other two legs yet. And then the rotor is going to just slide down over the top of this by then. So I got some more drilling to do. I got to figure out the cables. I've ordered some more Molex connectors, but I don't have them. So I just may take some longer rotor cable and splice it in this. And I have to see what coax I have at the moment. I'm just going to set this out behind the ham shack and see how it works. This would work better if I used two hands. I got my center punch out and gave that a couple bangs. Well, here it is. The rotors are on the piece of mast, holds them together, and then here's the azimuth rotor down here. It's all clamped on with the little piece of mast that goes down in here with a pin here just to hold it. Basically, while you get this pin in down here, there's a lot of weight there. Those two rotors are a little heavy. Then I just need a cross boom to go in there and mount the antenna. So I've been busy splicing rotor cable. The pieces I had that I were using back in Grass Valley are about 40 feet long, so I added another 20 feet. I had some heavier duty rotor cable that ran out to my HF tower. It was about 300 feet long, so it's a much larger gauge. So it's all spliced in. See how it all works. Well, now it's Sunday morning, July 20th, and I'm going to set up the antenna somewhere kind of out in this space here. First thing I need to do is check to see if I have enough rotor cable to get over to a spot and into the house. So, string over one of the cables. I've wired up the control box. I have all the cables on the back and have the rotor sitting here. And these are the Molex connectors that I use. This cable is really old. It's probably been outside for many years. And what I want to make sure here is which way the rotor is pointing before I put it on the mast or the tripod. So it's azimuth is due north. And the elevation is at 135. So I'm going to crank that down to 90. Actually, I'm going to crank it down to 0. The elevation rotor is slower than the azimuth rotor. So I know I can point the antenna that way. Okay, so we're just down to 0, and we'll stop it there, shut it off, and disconnect the cables, and we'll start putting the tripod together. So here's the center of the tripod. You see the legs go through it and up through there, and I've drilled holes to have it pinned, and everything's labeled. So let's put it together. Okay, now I'll set the rotor in here. So I have a pin here that keeps it from dropping all the way down. So let's see if they go through there. There's one. I have marks on there to line them up. Here's leg number 3. There it goes. Leg number 2. Need to twist that just a bit. There we go. And the next one is pin the rotor in. I'm gonna spin it around here. Okay, there's my mark. This goes in here. And that's in. So now the legs and everything will stay in there. So I'll just mention here that this is just a temporary situation. I'm using a piece of PVC tubing to hold the antenna. There's that. I can stick it out the other side a little bit, like that. These are the brackets that go on there. I can tighten these down because I can adjust the antenna. And I really like these ratchet wrenches. Better than sockets a lot of times. Of course, I can't tighten this really, really, really tight. They can crack the tubing. But again, this is a temporary setup. This is not how it would do something permanent. But, you know, this would be, at least so far, you know, a nice field day or portable type of setup. That should do. Well, I see my first problem. I don't want to have it mounted this way, so I got to loosen this up and turn it 90 degrees. Okay, let's try this again. Of course, you always have a 50-50 chance of putting the wrench on the wrong way. All right, let's plug these back in. This one's elevation. What's this cable here? Yeah, these connectors, they've been outside for a long time. They're all kind of corroded, so I've ordered, I think, a dozen new 6-pin Molexes. These I'll throw out. I know I need to have this north, so let's pick this up and turn it around. And get out my compass on my phone. Good enough. Okay, it looks like it's pointing down a little bit. It's about as low as I can get it. All right. So let's go up to 90 degrees. Turn it on. I got my rope just above it for my 80-meter dipole, so I clear that. And I have a CSN rotor controller, and it will allow it to go all the way 180 degrees. So when it gets at a very high elevation, it doesn't have to spin it around, spin the azimuth rotor around 180 degrees to catch up with it again. Okay. This is down now. And let's swing this around to the south. Yeah, okay, that's turning it to the right. Down. 90 degrees. And go south, all the way down. Okay. The next thing I need to do is plug in the CSN controller, and I need to calibrate it. Okay, so here's the CNS Technologies SAT, satellite tracker, and it's just a little self-contained box. It has a couple connectors on the back here, so power. It has a relay, so you can have a closure when the pass is happening. It's got a connector that plugs into the back of the Yaesu rotor controller, and another connector for radio. Uses the CIV going into the IC9700, and I'm just powering it with this Anchor battery here. And it connects to my computer using Wi-Fi. So I point my browser to 192.168.1.42, and you're really not going to be able to see much out here, but it brings up a web screen. It's got a little web server in there, and that's how you control it and do the setting. So it says, before connecting the rotor, manually set the azimuth and elevation to their minimums. And it says on the G5500, blah, blah, blah. On the 5400, this is 180 degrees azimuth with the needle to the left and 0 elevation. So I'm there. I have the azimuth to the left, and we're at 0 degrees elevation. Okay, you can't see the screen, so I'm just going to let you watch the rotor here. So I'm going to push the auto cal button. We'll see what happens. Okay, I get a warning just to make sure. It can take up to 4 minutes. Hit OK, and off it goes. So what it's going to do here is it learns the voltage levels from the elevation and azimuth pots in the rotor for both the 0 position as well as essentially the full scale, so it can know what the range is. So it's running the elevation through. It says auto calibrate on the display of the CSN. Okay, this antenna I have, it's a Cushcraft antenna. I probably had it from about 95, set up in Grass Valley. So it did that. Now let's see what happens. Here's a little pulse there. So this is a Cushcraft antenna. It's 5 elements on 2 and 5 elements on 440, and it's set up for FM, but it's what I have. So on the 5400, I want 180 degrees azimuth with the needle to the left and 0 degrees elevation. Well, it's been a while. So I got that small antenna on the mast, got the tracking going. I ran some RG-58 into the house. That's all I had. And I wasn't very happy with the performance. I just figured out that probably with the RG-58, I was losing, about 5.5 dB maybe, just through the cable. And then on the back of my 9700, I have a diplexer, so I can bring in on one cable the 2 meter and the 70 centimeter signal and then split it. So I'm probably losing another dB there. So I was able to hear stations weekly, but that was just a quick temporary. So I've removed the combination 2 meter 440 beam, and I've placed it up on the top of my tower to increase my 2 meter range. I'll show you what I have next here to work with. So what I have in the back of the gator here is my new 2 meter antenna. This is part of a KOM-22C. So that was 11 elements in the X and 11 elements in the Y dimension, but it's like 19 feet long, so too big to use to bother with. So I've left a couple of the boom sections off. So I have 1, 2, 3, 4, 5, 6 elements H and V there, or X and Y. So this antenna here next is half of a French made, I forget the manufacturer. It was 19 elements in both the H and the V direction, and it was 10 feet long. So I only have half of this, and I've actually removed one of the elements. So I have 1, 2, 3, 4, 5, 6, 7, 8,
9, right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so I have 9. So what we have here is the fiberglass boom. This was on the antenna system when I bought my house in Grass Valley from the ham there, and that was in 1990. So these things are pretty old, but be pretty expensive to buy today. They've had some weathering damage where, you know, the fiberglass, the little fibers have were starting to flake, right? And if you handle it, you got the little fiber splinters. So I got some epoxy paint, and I painted them. And it's got an aluminum piece that goes through the rotor, and then the other section puts on there. And I'm going to replace the RG-58 coax. I ordered up 200 feet of the 400 Ultra Flex. So a piece of this is up on the tower to feed the new 2 meter, 70 centimeter beam. And this is what I'm going to run into the house. This I estimate I'll have about 1.3 dB loss, and I'll go straight into the radio. So I'll probably pick up 4 to 5 dB just with changing out the coax. Plus I'll have more antenna gain. So I should have a much better received signal. And I have 3 more of these aluminum legs to use for the tripod. I think I haven't checked it yet, but the 2 meter antenna may be too long. We'll have to see. And other things are in here. You know, whenever you're dealing with any antenna project, you need your sets of deep sockets. These are just, you know, good old Harbor Freight ones, but you need them both in metric and also the American. You know, the ASE, I guess it is, because like the rotor stuff is all in metric. Well, I've got the new boom mounted along with the antennas. They're just kind of on there temporarily. Of course, right here is the 435, over there's the 2. So I was able to do one without taking it apart. See if I can do the other one. Ta-da! I think that'll be a lot more stable. So I'm going to drill these so I can put some of these pins in there. That way, pin goes in there and I'm all set. All right, time to spool off some cable. I'm going to lose the microphone when I get over to the other end here. So I'm going to have a bunch of extra to get into the house, up to the radio. I've dug a couple of holes to try and get things leveled up more. So this antenna is set up so you can switch it between left and right circular polarization. So here's the phasing harness, here's the combiner, and then here's a relay that if you send it up 12 volts, you can switch it back and forth. In its off position, it's set up for right hand. With the low orbiting small satellites, you really don't need circular polarization to match the satellite. What it does help a little bit is as the satellite tumbles, the polarity of their antenna is rotating around, so you may get a null. Also what I've done is I put electrical tape on here. I don't know how well it shows up, but it's brown, yellow, green, and that's for 145. So I know that's the VHF. The other antenna has tape on there for 435. Well, that's a wrap, I think, for out here. I have enough of it together so I can go inside and play around. When I get things situated properly inside, I'll continue on with the video. Okay, got the camera off here to the side. So we're going to try an RS-44 pass. I'm using the CSN tracking. This is the web interface to the box. It's going to control the rotor and the radio. We receive on 435 and transmit on 145. It's here, I don't know if you can see it. Shows how the satellite will pass over the sky. It's going to start off just about due south. It'll go up to a maximum elevation of 76, and then turn around and set about 10 degrees off of north. And here they come. And that's at 5 degrees. And with the CSN controller, when I tune the receive frequency, it's also moving my transmit to keep them lined up. And we use the receive incremental tuning to get both my transmit and my receive, so I can hear myself, so I get zero beated. And yesterday I had to have minus 1.5 kilohertz of RIT. WA6 JKN K7AGE.
Yeah, I heard a kilo 6 in there. Try again.
I didn't hear myself, so.
Yeah, kilo 6 Foxtrot Echo Uniform. Thank you very much for the call. This is WA6
There it's coming up.
Juliet Kilowatt November Charlie Mike 97. Over.
That's you, Kevin.
Yeah, thank you for the grid square. WA6JKN calling N60VP. David, I think I heard you in there, by golly.
Yeah, you did. 87 degrees today. Wow.
Oh, yeah, I figured I'd get in here early.
Yeah, pretty low.
So I have 15 minutes to go here, so.
This makes all the difference. Over.
Yeah, I think I got up to about 6 or 7 degrees, and I started racking in the calls. I've worked N5ZYZ, Yankee Echo Zulu, W5QZ, Alpha Alpha 7 Nancy, and K6FEU, and now N60VP.
Wow. Amazing. That quickly. Well, I was on CW last night and worked Hungary, which I haven't been able to contact that many times. Over.
Oh, yeah, that's
I see another station down here, I think.
India Zulu Echo Lima 08. CQ satellite November 5 Yankee India Zulu and Echo Lima 08.
November 5, Yankee,
Again?
Kilo 7, Alpha Golf Echo.
Again, what's your call?
Kilo 7, Alpha Golf Echo.
Okay, yeah, you're a little light. Is it kilo 6 something?
Kilo 7, Kilo 7.
Oh man, I'm not kidding you. Give me your call again.
Kilo 7, Alpha Golf Echo.
Okay, say kilo 7 Alpha Golf Echo.
Roger, roger.
Okay, kilo 7 Alpha Golf Echo. Gotcha, my friend. I'm in Echo Lima 09. Or sorry, Echo Lima 08.
Very good. I'm in Charlie Nancy 72. Charlie Nancy 72.
Okay, CN 72. Thanks for the contact. 73. November 5 Yankee
73.
November 5 Yankee India Zulu. Echo Lima 08.
Put him in the log here.
Thank you, satellite. November 5 Yankee India Zulu and Echo Lima 08.
That's one.
Thank you, satellite.
It didn't sound like I was hearing myself very well. Let's see if I can zero myself in. Well, usually use headphones, but you won't be able to hear. Kilo 7 Alpha Golf Echo. Hello, satellite. I don't hear myself now.
Idea is pretty amazing. I'm going to go down to 4 watts. Now I'm going down to 3 watts. 2 watts. Now here's 1 watt. Now I'm going to go to 0. Hello, 0. So that's pretty amazing.
I don't know if that's feasible. I'm at 5 watts. Is 0 actually feasible? If you have 0, you shouldn't hear anything.
Well, there is RF coming up, but it's really, really small. It's like a milliwatt or so.
Wow, yeah. Well, there's 5 watts. I found Whiskey Delta 5, Golf, Romeo Whiskey, Central 923.
7 November again.
I had coax antennas, I think, that had relays on them for left and right.
See, it's a lot different than the FM satellites, where they just send their call sign and grid square. You got some time here, you can actually have a conversation.
Whiskey 5, Quebec, Zulu, Echo Mike 10. PQ satellite, Whiskey 5, Quebec, Zulu, Echo Mike 10.
Whiskey 5, Quebec Zulu from Kilo 7, Alpha Golf Echo.
Alpha Echo again, please.
Yeah, Kilo 7, Alpha Golf Echo. Charlie Nancy 72, Charlie Nancy 72.
QSL, this is Whiskey 5, Quebec, Zulu, Echo Mike 10.
Very good. You're my third contact here on RS-44. Just got the antennas running yesterday.
Yes, Echo Mike 1.
Roger, Roger. QSL. And get him to go on.
Repeater frequency where everybody's swapping.
Notice the Doppler control of the radio is working good. It really, his pitch is staying the same, steady. They chase each other a little bit. If the Doppler correction wasn't happening to the radio, you would just hear them move right out of the tuning.
It's kind of organization is covered. WA6JKN is clear.
WA6JKN from Kilo 7, Alpha Golf Echo.
Yeah, there's a Kilo 7 there. Losing the satellite. Hello, radio. Yeah, losing the satellite. I didn't get your call.
Kilo 7, Alpha Golf Echo. Charlie Nancy 72. Oh well, it was really strong, and then it's still at 30 degrees elevation here. It's headed, let me bring up a bigger map here. I don't know if it'll show up very well. Yeah, a little hard to see with the camera. Here's the footprint, so it came just about due north. It's up over British Columbia, I'd say now.
Satellite, Victor Alpha 7, Lima Mike, rolling, Charlie Oscar 55. Whiskey Alpha 4, hot Friday night. Whiskey Alpha 4, Hotel Foxtrot, November, hi Damon, you're 5'9", Charlie Oscar 55. QSL, Charlie Oscar 55. Thanks for the new grid. Good to hear you. 7-3. Good to hear you as well, my friend. 7-3. QRZ, Victor Alpha 7, Lima Mike.
Kilo 7 Alpha Golf Echo.
Denmark, 0 Canada. November Delta 0 Charlie, 59 Charlie Oscar 55. Randy?
US Alpha, you can do what you 59 Echo Nancy 23, half 173.
USL 73, thanks for the call. QRZ, Victor Alpha 7 Lima Mike, roving in Charlie Oscar 55.
Kilo 7 Alpha Golf Echo.
Kilo 7 Alpha Golf Echo, Randy, you're 59, Charlie Oscar 55.
Oh, very good, very good. I'm in Charlie Nancy 7-2. You got a good signal. You're about my fourth contact on RS-44. Just got my antennas running yesterday.
Okay, Randy, good to hear you. Thank you very much. We got everything. Thanks for the call. QRZ.
That's another one. VA 7LM. Roving. It's probably pulled over the side of the road and has some type of antennas. Bring up his QRZ real quick here. Victor Alpha 7LM. Wow, look at all the grids he's worked here. He's worked somebody out here before. So he's in Charlie Oscar. Look at grid tracker. Charlie Oscar, okay, he's up here. He's just about in the middle of the Charlie Oscar to CO grid, kind of on the coast of British Columbia. It's at 10 degrees now. What was his name? Doug, okay. He must have known me from my videos. So anyway, I'm going to call that to the end of my satellite antenna video. It works a lot better than that combination 2 and 445 element beam. There's no preamps out there. I see 9700. JT Alert just alerted me on a new marathon, so I'm going to say 73 and go chase him now. Thanks for watching. Give me a thumbs up, please, and subscribe. And see you next time. Randy, K7AGE.